Today we're going to be talking about how to find the parametric equations of the tangent line. And in this particular problem, we've been given three parametric equations that define our function: x equals e to the negative t times cosine of t, y equals e to the negative t times sine of t, and z equals e to the negative t. And we've been asked to find the parametric equations of the tangent line to this curve at the point 1, 0, 1. So the first thing we need to do, because we have parametric equations x, y, and z defined in terms of some parameter value t, we need to find the parameter value for t that corresponds to the coordinate point 1, 0, 1. The way that we're going to do that is by setting each of these equations equal to the corresponding value in this coordinate point. So 1 here is the x value in the coordinate point. We're going to say 1, we're going to replace x with 1 and say 1 equals e to the negative t cosine of t. Then we have a y value in our coordinate point of 0, so we're going to replace y with 0 and say 0 is equal to e to the negative t times sine of t. And then our z value is 1, so we'll replace z with 1 and get 1 is equal to e to the negative t. Now we need to find a parameter value for t that's going to satisfy all three of these equations. Well, let's look at our third equation here because it's the simplest equation. If we say e to the negative t is equal to 1, which value of t is going to give us a value of 1 on the right-hand side? Well, the obvious answer there is 0 because we'd have e to the 0 and e to the 0 is equal to 1. We'd get 1 equals 1 and that equation would be true. So maybe the parameter value we're looking for is t equals 0. Let's try it in our other two equations. If we plug t equals 0 into this first equation, we'll get e to the 0, which is 1. Cosine of t, or cosine of 0, cosine of 0 is 1, so we get 1 times 1, which would give us 1, so that does work. If we plug t equals 0 into this second equation, again we'll get e to the 0, which is 1. Sine of 0 is 0, so we get 1 times 0, or just 0. 0 equals 0, so that works as well. So t equals 0 is the value of the parameter that corresponds to our coordinate point 1, 0, 1. And remember, this coordinate point is the point where we want to find the equation of the tangent line. So how are we going to find that tangent line? Well, our next step is going to be to take the derivative of our function r of t. Well, you don't see a function yet, r of t, but essentially we have one because we have these parametric equations. Our function, r of t, is just equal to, if we put this here in component form, in vector form here, we take these x, y, and z values, and we say that we've got that function r of t. So e to the negative t cosine of t, we're just taking these directly from the parametric equations of our original function, e to the negative t sine of t, and e to the negative t for z, like that. So that's our function r of t. We need to take the derivative, which we'll call r prime of t, and remember that that's just going to be the derivative of our vector r with respect to the parameter value t. So taking the derivative of each one of these components with respect to t, we'll need to use product rule for this first one. We'll treat e to the negative t as one function and cosine of t as the other, and we'll use product rule. So remember, if we're using product rule, we take the derivative of one of our functions. The derivative of e to the negative t is negative e to the negative t, and we multiply that by our second function without doing anything to it, so cosine of t. But then we add to that the opposite situation. Here, we're not going to do anything to e to the negative t, so e to the negative t, but then we have to multiply that by the derivative of cosine of t, which is negative sine of t. So there's the derivative of our x component, our first component there. Now we move on to our y component. We're going to do the same thing here with product rule, pretending that e to the negative t is one function, sine of t is another, and we need to use product rule to take the derivative. So the derivative of e to the negative t we already know is negative e to the negative t. We multiply that by sine of t without doing anything to it, and then add to that e to the negative t, this time we don't touch that first function, multiply by the derivative of our second function. The derivative of sine of t is cosine of t. So there's the derivative of our y component. Then our z component, the derivative of e to the negative t, is negative e to the negative t. So here's our derivative function. We just want to simplify it as much as we can. We'll get here negative e to the negative t times cosine of t. We'll bring this negative sign out in front here and get minus e to the negative t sine of t, like this. We'll go ahead and flip these around since this starts with a negative sign. So we'll get e to the negative t cosine of t, and then subtract e to the negative t sine of t. And then our third component is just negative e to the negative t. Now, in order to find the tangent line at the value of the parameter t equals 0, we need to evaluate our derivative at that parameter value. So we're looking for r prime of 0, in other words, whatever we get when we plug t equals 0 into our derivative. So here's what that looks like. We're plugging in 0 for t, so here we're going to get e to the 0. That's just 1, but we have this negative sign in front, so we're going to get negative 1. Cosine of 0 is just 1, so again still just negative 1 for this first term. Then we have minus e to the 0, again e to the 0 is just 1, but sine of 0 is 0, so 1 times 0 we get a 0. We don't need to subtract 0 here, we'll just call this negative 1. Now for our y component, we get e to the negative t, or e to the 0, that's 1. Cosine of 0 is 1. 1 times 1, we just get a positive 1 there. Then we have minus e to the t. E to the 0 is 1, but sine of 0 is 0, so that's going to cancel the second term. We're just going to be left with this positive 1. Then for our third term, negative e to the negative t, plug in 0 for t, and we get e to the 0, which is 1, but we have this negative sign out in front, so we're going to be left with negative 1. Now at this point, here's what we know. We know that the tangent line is parallel to this vector. So we found r prime of 0, or the derivative of our vector function at the parameter value t equals 0. Our tangent line is parallel to this vector, and it runs through the point 1, 0, 1. So now, in order to write parametric equations for the tangent line, we've got everything we need. Remember, our parametric equations are going to be in the form x equals, y equals, and z equals. And to find these parametric equations, here's what we do. We take the corresponding value from the coordinate point. So for our x equals equation here, we take the x value from our coordinate point, that's 1, and we say 1. Then we add to that the corresponding value from our vector over here multiplied by the parameter t. So we add to that the corresponding value over here, negative 1, and multiply it by t, so we get negative 1 times t. Now for our y equation, we take our y value here, we get 0. Then we add to that the corresponding value from our vector, which is 1, and multiply that by t. Then for z, we take the corresponding value from our coordinate point, which is 1. Add to that the component from our vector over here, which is negative 1, multiplied by t. So that's how we set it up, but now we just want to simplify. We'll get x equals 1 minus t, because we've got this negative 1 here, so this just simplifies to 1 minus t. For y, we'll just get t, the 0 goes away, and the coefficient of 1 is just redundant. We get y equals t. And for z, we get 1 minus t. These are the parametric equations that define the tangent line to this original function at the point 1, 0, 1.